In the previous lecture, we completed the implementation of a Contacts app class that we had over on Objective-C, and that we now have brought over to this Contacts app project with Xamarin Forms. Now, during this lecture, what I want to focus on is on other thing that we have already seen how to do on Android, but we haven't seen yet here on iOS, which is simply the linker behavior. How I said that linking is going to help us reduce the app size in iOS, just like it did on Android. And everything that we mentioned on the case of Android is going to apply for iOS as well. In iOS, if I right-click on the project and go over to Options or Properties on Windows and navigate over to iOS Build, we're also going to have a linker behavior option. And again, just like on Android, when we are on the debug configuration, this is set to don't link. And if we change, for example, to App Store, which means that this is actually going to be deployed to devices, these will set everything to link framework SDKs only, which again is pretty much identical to what we have over on Android. The thing with the linker here is also that it is going to search for all of those assemblies that are not necessarily being used. So all of those unused methods, properties, fields, events, structs, and even classes are going to be removed, so the overall size of the application is smaller. And just like we did see on Android, if we do want to preserve some parts of our code, we can do that in a very similar way. Now let me go ahead and show you exactly what is going to be the impact. If we set this to App Store, let's say that we're already going to be generating the IPA for our App Store deployment and set this to don't link, click OK. Let me go ahead and change the mode to App Store, and this will mean that I have to build for a device so I can archive this for publishing. Again, I am not really going to generate the IPA and publish. I just want to show you what the impact of linking is going to be. As soon as we see this generated, we see that this is even going to be bigger than what we saw on the Android version of our application. This is going to have an estimated App Store size of 84 megabytes. This is just huge for an application that really does nothing at all but show a small message on a label. Now again, the reason why don't link exists is really twofold in this case. One, of course, is to test, just like I mentioned in Android, if your application works with no linking enabled. If it works with no linking enabled and it doesn't work with SDK linking, it means that the linker may have some impact in how your application works, and you will have to do a little bit of testing to identify exactly what type of code is it that you want to preserve for your application to work with linking enabled. And also, it's just going to make it faster for you to test. The linker is going to be a little bit heavy when it comes to cleaning, of course, your own assemblies and the assemblies that are coming from the SDK. So while reducing this app size is going to be of great importance once you are going to be deploying to devices, and actually when you deploy to devices, the linker always has to be enabled, it just takes a bit. So if you're just testing, you don't want the linker enabled. That's why it's not enabled when debugging. But let's go ahead and test what happens, what impact is going to be there if we change this back to link framework SDKs. I am going to build this up, and by the way, I didn't mention this, but if you do want to create the archive, you do want to set some provisioning. So here I just set the automatic provisioning, so I don't really have to do anything. Visual Studio does everything for me. But just a quick note in case you weren't able to generate the archive, it's because of this probably. But let me go ahead and now with the SDK linking enabled to archive this again. We're also going to see a great impact when it comes to the estimated App Store size. In this case, just by enabling the linking of the SDK assemblies, we have reduced the estimated App Store size from 84 megabytes down to 24 megabytes. So you can see here I have this archive now with the SDK assemblies enabled. And something similar to what happened on Android is going to happen here on iOS if I go ahead and instead of linking only the SDKs, I link all. It is likely that the effects are going to be smaller. So let me go ahead and just rebuild for this mode and archive for publishing. As you can see in this case, we don't even see a difference. The estimated App Store size is going to be pretty much enough to what it was with the SDK assemblies only. Now, finally, I just want to show you how the same thing that we did see on Android when we want to preserve certain parts of our code is going to apply here to iOS. So for example, right here in the constructor for our contact class, if we also had, again, some code that we want to preserve, we will be able to do that by establishing the preserve attribute to this particular part of our code. This is coming from xamarin.ios.foundation, which is right here already. And this will help me define that the constructor has to be preserved even when I am linking everything, every assembly, including my own assemblies. And the same thing is going to happen if I want to preserve the entire class. I can set it to preserve and set that I do want to preserve all members. So set all members to true. And again, just like on Android, we can set a conditional value when preserving the contact. So again, if this is set to false, the preservation of the contact is not going to be conditional to the preservation of the entire type. As we are setting all members in here, preserving all members, and this conditional to false, this is going to be preserved regardless of what all members is set over here to the type from where the constructor is coming. So if I still set this to false, because this is not conditional, this will still be preserved, even if the entire type isn't. On the other hand, if I set this to true, this is conditional to the preservation of the entire type, then, because the preservation is set to false to all members, these will not be preserved. But if I change this back to true, then it will. So I just wanted to add this quick note here in this section for you to understand that this is also going to apply to iOS. Just like we did in the section for Android, we're going to be able to set some linking behavior and set to preserve certain parts of our code in case the SDK linking is really helping us reduce the code size, but it may in some scenarios also impact the way our application works. So you want to make sure that you preserve certain parts of our code that are going to be necessary. In most scenarios though, linking the SDK assemblies only is going to be more than enough, and your code will always work just as you expect, but with a much smaller application size when you deploy over to the stores. Hopefully, with these small examples that we took a look at in the Android and iOS sections, you now know something very important when it comes to building Xamarin applications. And that is the fact that you can bring Java and Objective-C code over to your Xamarin Forms applications just by creating a bindings library. That is the main takeaway that I want you to keep in mind when it comes to these two sections that we had on Android and iOS. It is going to be really important because, as I explained in one of the previous lectures, it is something that many times Xamarin developers don't know that they can easily do, and it limits them as to what they think they can do with Xamarin when it's actually quite straightforward, and all of the code that you already have on Java and Objective-C, even all of those libraries that you already have, can be brought over to your Xamarin projects. Of course, also linking behavior is important, but the fact that we are now using here some Objective-C code in the case of iOS and some Java code in the case of Android, I think is going to really up your game as a Xamarin Forms developer.